How's it going?
It's going well. How are you?
Oh, not too bad.
Okay, good. Boom, boom. Okay, it's 12:12. So let's go ahead and begin. Okay. Back. Okay. Nope, got one more. Let me update that. And Tyler. Okay. All right. So for bell work today, we're going to pick up where we left off on Monday. I need you to convert each of these to the other. It should say angle measure here. Angle. So convert 135 degrees to radians and convert 3 pi radians to degrees. I'll give you 3 minutes. Okay, so I'll do the first one and then I'm going to ask for help on the second. To convert something from degrees to radian or radians to degrees, you have to multiply by the conversion rate. So I'm going to multiply this by pi radians over 180 degrees. Since I'm going from degrees to radians, I want the pi radians to be on top and the 180 degrees to be on bottom, because then the degrees will cancel out, leaving me with 135 pi over 180. Now, so that's the angle in radians. Now I could, and I should, simplify this since both of those numbers are divisible by 45. And that gives us 3 over 4 pi radians, which should make sense. If you think about it and you draw a little graph, this angle right here is 135 degrees, or this portion right here is 45. And so if this is pi radians is 180, and pi over 2 is 90, then this angle is right between those two, so it's 3 pi over 4. All right, so who can help me with B? What do I have to multiply this by to get my answer?
$180 degrees over pi.
That's right.
Radians.
Yeah, same rate, but you just flip it, where the 180 has to be on top. And the radians is now on bottom because I want to cancel out the radians and just have degrees left. The nice thing about converting the radians to degrees is the pi's will also cancel out. And so really, this is just 3 times 180, or 540. Okay, any questions? Sweet. Then we're going to finish out 4.1 today. So we already did that, We're going to just did that. Boom. So we're going to start talking about how to use angles to solve some more problems. First set of problems that they ask you to do, to be honest, you don't have to copy this into your notes. This is This is from geometry. This is just a review of some vocabulary that you'll need for some of the problems. When they talk about complementary angles on the homework, those are angles that add up to 90 degrees. When they talk about supplementary angles, those add up to 180. So I'll give you a moment to copy that down as a refresher if you would like, before we move on and start really solving some stuff with that. Okay. All right. So now that you have that refresher, let's see if you can solve this problem. I need you to find the complementary and supplementary angle for 72 degrees. 2 or 3 minutes. Okay. Why does this say 1 of 4 responses? What the heck is going on here? All right. Who's in here? 1, 2, 3, 4. Let's roll the dice. Get here with this. 3. Okay, so who's the third person in here? Hey, Jackson, can you help me out? What is the complementary angle? Oh, gee. Oh, he told me he had to go. That's fine. Ty, never mind. Ty, what is a complementary angle with 72? Or in other words, what plus 72 gives us 90?
18.
Hey, good job. All right, let's just keep going down. So then, Abigail, what's the supplementary angle with 72?
108.
All right, very good. Okay. I was scared at the beginning, but you got it. All right, good job. Okay, next. The next thing, okay, you don't have to write this down in your notes. This was actually in your notes already. You can if you would like to. This formula that they are giving you is in your notes already. We wrote it on Monday. Those are the same thing. So another real world problem that they'll ask you to do is to find the arc length and or radius of a circle, given, again, the other two parts of this formula. So this is the formula solved for S, where you multiply R to both sides. Please note, though, that this formula, either way that it's written, again, those are the same thing, can only be used to find arc length if your angle is in radians. These formulas only work when your angle is in radians. They do not work if your angle is in degrees. Right, so I'll give you another minute to copy this down if you like. Again, you don't have to. And then we'll do an example, and then I'll have you try one. And then we're almost done with class. Okay. All right, so now let's do it. So, these are the type of problems that you'll see in like the ACT homework quiz test. Let's say we have a circle with radius 4 inches. We want to find the arc length created by a central angle of 240 degrees. So if you draw a picture of this, you don't need to draw a picture of this, but if you did, it would look like this. So we have this circle of radius 4. The angle is about right there. This is 240 degrees. What we are asked to find is how long is this arc length here? From here to here, going along the edge of the circle, how long is that distance? All right, to find that out, we're going to use our formula that the angle is in radians is equal to the arc length divided by the radius. However, if you plug in straight from here, you're going to get the wrong answer because this is not the angle in radians. To make it the angle in radians, we need to convert it by multiplying by pi over 180 to get 240 pi over 180. But again, you should simplify this. Both of those numbers are divisible by 60. So you'll get 4 pi over 3. And now this is what you should plug in to your formula. So if you plug those in, we get 4 pi over 3 is equal to s over 4. To solve this for our arc length s, we need to get rid of this divide by 4. So multiply both sides by 4 to get s is equal to 16 pi over 3 inches, which is about 16.775. Yay? Any questions on this? All right. Then it's your turn. Same type of problem. Find the arc length given a circle of radius 27 and a central angle of 160 degrees. Okay, so let us see how we're doing on this. Okay, we did worse. This has no responses. That's worse. That's worse. What is going on here? There's only like 4 of you. Okay. So let me know. Are we stuck on this, or are we just didn't type in the answer? Or I think let's just keep going in order. So, Anna, I think you're next up. How would I solve this problem?
First, you have to make the degrees into radians.
How do I do that?
You multiply the 160 by pi over 180.
Yay. Okay. And what does that reduce to? Was that both divisible by 20? Is that the biggest number? I think.
Yeah, it's 8 over 9.
Yeah, 8 over, yeah, okay, yep, that checks out. And both are divisible by 20, so that gives us 8 over 9. Okay, very good. All right, now that I have my angle, what do I do?
You put it in our equation.
Very
So
good.
it's the 8 over 9 equals the s over 27.
Yep, so we're using that same equation we had earlier. And this problem, we're given r and theta, so we plug those in. We have s left over, which is what we're trying to find. And to solve this, we'll multiply by 27. Very good. And actually, this is not that bad of a multiplication to do because 27 divided by 9 is 3. So this is 3 times 8 is 24 inches. Or if you did round it to a decimal, you should have gotten 75.398 inches. Okay, so hopefully so far in this class, this has been easy peasies lemon squeezies. Now let's make it not so easy peasy lemon squeezies. Does anyone need more time on this or have any questions? Okay. All right. So the last type of word problems they're going to have you solve are about speed. And there are 2 types of speed that you have to distinguish between. So you don't need to write down all this text if you don't want to. But what you should have down is this formula and this formula. And it might be prudent at this point in the class. The trig has a whole bunch of formulas that you'll use. There is a reference sheet in the book, but it might help you to make your own reference sheet. So you might start a new page with your formula sheet, just like a page that we're just putting equations on. And so far we have had one, which is the theta equals s over r, which is central angle in radians equals arc length over radius, right? And you might add these 2 to that formula sheet. Again, you don't have to do that. It just might help you to have all your formulas on one piece of paper for the whole semester. Okay, what is the difference between these 2 things? With linear speed, we're talking, imagine a wheel and you put a penny or a dot on the edge of the wheel. How fast that penny or dot is moving around is the linear speed. I know what you're thinking. You're thinking, Mr. Lake, that circle was terrible. There we go. I did that freehand. So how fast that dot is moving around the circle's edge over a period of time is your linear speed. So that's the arc length s over t, how long it takes to cover that ground. The angular speed is for a given, again, imagine a wheel, But this time, we're not looking at the edge of the wheel, but we're looking at the angle that the wheel is rotating. How many degrees or radians or revolutions is usually the most common unit in a certain amount of time. So the units for linear speed is a distance divided by time. So it's going to be stuff like usually like inches per second or feet per minute, right? It'll be those kind of units. For angular speed, where we're talking how fast is the wheel rotating, that's going to be given to you in like degrees per second. Okay, I should, that degrees per second, or like radians per minute, or a very common one usually they'll do is revolutions per, second. All right, so do we understand the difference between linear speed and angular speed? Okay, I think, hold on. I think, what is the, yeah, okay. So I don't know why they don't put it in the book either, but they don't actually tell you what the variable you should use. For linear speed, we usually use the variable v. And for angular speed, we use the Greek letter. It kind of looks like a W, but with like more curvy in the whatever. It's more curvy. It's like a weirder W. I think that's called sigma. Is that the right one? What is that symbol? I think it's sigma. No, it's not sigma. W, Greek letter. It's wow. W-A-U. That's what that letter is called. That's not right. I don't trust you, whatever website you just said that. Omega, that's it. I'm like, that is not wow. Or maybe it is, and I just don't know what I'm talking about. But omega, that's what I was looking for. The Greek letter omega. Thank you. Okay, anywho, I actually don't think it's going to ask you about any of that on the homework because the book doesn't even want to talk about it at all. So there's that. All right, does anyone need more time on this slide? Are you ready to see some examples? Sweet. Okay, so I will tell you the hardest part about these examples is just getting started because they will sound complicated and intimidating, and don't let them intimidate you. These are all doable word problems, especially if you organize your answers. So first example, let's say we have a clock. The second hand of the clock is 10.2 centimeters long. We want to find the linear speed of the tip of the second hand. So what will help you stay organized and able to solve these is to write your givens first. We are given that the radius is 10.2. Although it's not explicitly stated in here, we are also given one other piece of information, that the second hand completes one revolution. I'll just go for one revolution in 60 seconds. Right? Second hand goes all the way around in 60 seconds. The next thing you should write is your unknowns. What are we trying to find? The linear speed. So what is the velocity? Next, you should write your equation. So then we go to our formula sheet and we try to find our missing variable on that formula sheet. And you should now have that velocity is equal to the arc length divided by time. All right. And now what we're going to do is we're going to see, well, can we find out what the arc length is? And can we find out the change in time? And to be honest, for most of these problems, you can pick the change in time, and then you're going to pick one and solve for the other. So I'm going to say, let's see how far the second hand moves in 60 seconds. So let's just arbitrarily decide, I want to see what is S when T is 60 seconds. The reason why I chose 60 seconds is because that's one revolution. So then S would be the circumference of the circle. Right? In 60 seconds, the arc that it travels is the full circle. So then the arc length would be 2 pi r, or 2 pi times 10.2. And since that's already a decimal, no, I'm not going to convert it to it. That'd be 20.4 pi centimeters. All right, so I'm going to pause here. Is there any questions about how I got the arc length? Where this stuff came from? Okay, once you have your parts of your formula, you can then substitute in your numbers. So I'm going to plug in for S, I'm going to plug in 20.4, and for T, I'm going to plug in 60. So I'll get V is equal to 20.4 pi centimeters over 60 seconds. And then usually there's a fifth step. For our problem, we don't really do it. But like for the earlier examples we did, once we substituted in, every once in a while you might need to solve for your variable. Our variable is already solved for. We already have V by itself. So really, this is our final answer. And now I'm going to go ahead and convert it to a decimal because that's more useful than what we have now. And that would be 1.068 centimeters per second. And how I got that decimal is I just took 20.4 times pi and divided by 60. I think we're going to get out early today. We just got one more slide left and 13 minutes. 18 minutes in class left? 18 minutes of class left with just one more slide to do. All right, is there any questions about this? To be honest, if you are going to solve this for yourself, I imagine you might not go into as much detail as I just did here. But if you use this process, write your givens, your unknown, the equation, substitute, solve, that process will work no matter how complicated a word problem they give you. And so as Ty will tell you, if you use guess, you'll never have to guess. Or if you've been in my class before, you probably have heard that. Though, to be honest, I stole this from Mr. Rupp, so this acronym here. All right. Okay. Let's have you try one. So the blades of a wind turbine are 116 feet long. The propeller is rotating at 15 revolutions per minute. I would like you to find the angular speed of the propeller, and I love some part out of it, in radians per minute, and the linear speed of the tip of the blade. So this first part is just convert how many radians per minute is 15 revolutions per minute. And then once you have that, find the linear speed. I'll give you 3 minutes. And then we'll check back and see if you need more time, because you might. Okay. So let's at least do the first part, and then we'll see if we need more time for the second. So Caitlin, I think you're next up. How many radians per minute is 15 revolutions per minute? Well, let me back up.
Okay.
how many radians are there in a full circle, full revolution?
Two. Ooh.
2 pi.
2 pi.
2 pi, that's right. Good job. Yeah, so 2 pi radians in every 1 revolution, right?
Yeah.
Like which if this was in degrees, it'd probably make it easier. There's 360 degrees in 1 revolution. And since there's 2 pi for every 360 degrees, or 1 pi for 180, so that means there's 2 pi in every 1 revolution. So this becomes, notice the revolutions cancels, 30 pi rads or radians per minute. Okay. All right. Thank you, Caitlin. How are we doing on the second part here? Do we need more time for the linear speed? Are we ready to go over it? Okay. You can put in chat. Just more time or ready to go over it? Okay. All right. Good. More time? All right. I'm going to start the timer over then. I'll give you 3 more minutes. Now you know what this is theta. Or sorry. That's not theta. That's omega. That's your angular speed. That means theta is 30 pi. Radians. R is 116 feet. I need you to find 2 things. I need you to find S. How far does it travel then? And let's say, to be uniform for everybody, let's say in 1 minute, right? So in 1 minute, it goes, pausing this timer. In 1 minute, it goes 30 pi radians. So if the radius is 116, use your formula, tell me what S is. And then once you know S, again, let's all set T equals to 1. Tell me what V is. Yes. Yes, it is confusing. That's right. All right, so if this goes 15 revolutions in 1 minute, and we convert that to radians, there are 2 pi radians in every 1 revolution. So that means it goes 30 pi radians in 1 minute. That's our angular speed. So let us all say, let's let T equal 1 minute. If I want to find the linear speed, I need to know how far does it go in that 1 minute. So if we go 30 pi radians in 1 minute, and our circle has a radius of 116, what is the arc length? That's this formula. Once you have S, you should then be able to find V. So I'll give you 3 minutes to work through that process and see where we're at. And then Caitlin, we'll talk again. Yeah, the angular speed and linear speed stuff are always a tough part of this chapter. That's fair. All right, Caitlin, let's finish this out. So I'm going to erase some of this stuff to give us some room. All right. So what do I do next?
I am still really confused.
That's okay. That's okay. You're not the only one. I got a bunch of chats that said the same thing.
Okay.
All right. So let's try. We're going to plug these in to this first formula. That way we can find out. So we're going to get 30 pi equals S over 116. All right. If I want to solve this for S, what do I do?
Take the 30 pi and multiply
By
116.
hot dog. Yeah, if we multiply both sides by 116, this is gone over here, right? And we have just S, which is what we want. And so that turns out to be 3,480 pi feet. Okay, now that we have S and we have T, we can find V. Let's plug these in for V. So V would be S over T, which the nice thing about picking 1 minute here is that's just like done. We don't even have to do any more. 3,480 pi divided by 1 is 3,480 pi feet per minute. Or if you wanted to make that, find the decimal for that, if you actually multiply by pi, you get 10,932.742 feet per minute. Which I know what you're wondering. How fast is that? That's 125 miles per hour. That's how fast the tip of the blade of those big windmills, wind turbines are going. Isn't that crazy? Like as you drive, I don't know if you all made this drive often, but if you go like I-70 west towards Colorado, you eventually get it like to a point where it's just like all windmills to your left and right. And it doesn't look like they're moving that fast, but they're going 125 miles per hour. And that's why wind turbines kill birds. But actually, they're supposed to adjust the model so that they do go slower. So I think the ones actually out west, to be fair, are going slower than the ones in this problem, because they make them, because they tried to save the birds by trying to make the propellers even bigger so it can rotate slower and still generate the same amount of energy. Because it's a big deal because of the bats that were endangered species, and bats get hit by the turbines. I know you're all very interested in that. You're glad you stuck around for the last 2 minutes of this class. All right, so it is 1:08. So you can feel free to log off now and head to 6th hour. If you run into any issues with the homework, you can let me know by email. I know some of the word problems are always tough because they're word problems. That's 100% fair. So if you need help getting started or any of that on any of the word problems, just send me an email and I'll help you set it up. All right. Other than that, I'll see you all tomorrow. Bye.